Hello all, this is Ishan Ayush and today we are going to implement convolutional neural network with MNIST dataset. So before going into the implementation part, let's understand what is MNIST dataset. So MNIST is a handwritten dataset which consists of data from numbers 0 to 9, that is 0 1 2 3 4 5 6 7 8 9. So these numbers 0 to 9 are the various classes we are going to classify in this problem. So this is a classification problem. So we are going to follow the implementation through the various phases or various steps, which includes import of the required libraries. Further, we are going to perform data preparation, where we will be starting with loading of data and then splitting the data into training and testing. Further, we are going to normalize the data for the range of 0 to 1, and then we are going to reshape the data to have a single channel, and then we are going to perform the label encoding for the label part, and then we are going to visualize the data, and then we are going to implement the convolutional neural network, building the model, further training the model. Then we are going to evaluate the model, performing the entire calculation of evaluation. So before performing the evaluation, we need to implement confusion matrix so that the evaluation matrices can be calculated from the true positive, true negative, false positive and false negative. And then we are going to prepare the classification report, and then we are going to predict the particular image is belonging to the particular class or not. So we are going to perform prediction validation. So let's start the implementation. So we are going to import the necessary libraries. So these are the necessary libraries such as pandas, numpy, matplotlib, seaborn. Then we are going to use sklearn for various purposes such as split and for getting the confusion matrices. And then we are going to import keras for the implementation of the model purpose. So let's start with the data preparation. So we are going to load the data. So this is the data part. So keras, dataset, MNIST, then data load. So as the MNIST is a data which is present within the keras library, so we are going to directly call it from the keras library, and we are going to split it into train and test data. So let's understand what are the size of train data and test data. So 60,000 image samples are present in train data with size 28 cross 28. Similarly, Y train contain the labels, that is whether it is from class 0 or class 1 or class 2 until 9. Okay. So similarly, X test is the image data. So we have 10,000 test data of size 28 cross 28. So this is representing 10,000 data of 28 cross 28. And Y test contains the label, that is label of the class, that is from 0 to 9. Further, we are going to visualize the data, for which we are defining a plot sample, and further we are going to use IMShow to present the sample. So we are going to see X train samples 0th data, so it is 5 and it is visible. Further, we are going to normalize the data, that is, as we know, the various pixels of the data is ranging from 0 to 255. So we are going to normalize the image data by dividing each pixels by 255 to get a normalized values which will lie between 0 to 1. So we are going to normalize X train data and X test data, which contains images. Further, we are going to reshape the X train data and test data on the basis of length of X train, that is total number of images present in the train data, that is 60,000 into 28 into 28 is the size of the data, and 1 generally represents, we are extracting single channel of the particular grayscale image. So after reshaping, we can check whether our data shape has been changed or not by using dot shape, and then we are going to perform the label encoding, so that sometime the classes are in the format of names, so we need to convert them into numeric values. So we generally use label encoding for that. So to categorical can convert the name data to numeric data, or strings data to numeric data. Further, we are going to perform the data visualization. So this is the visualization part. So we can see these are the images, handwritten images, and these are the what are the labels, and these are the labels. So real number is 5, so 5 is the label, 0 is the label, 4 is the label, 1 is the label, and these are the image samples. Further, we can perform other normalization, such as here we have performed a standardized normalization where we have used each samples and each pixel values to be subtracted from the mean and then divided by the standard deviation to get a standardized values, and its value also ranges from 0 to 1, and this can be avoided in some cases. So and we can use other standard normalization techniques such as mean max normalization also. Further, let's dive into the model part. So this is the model. So we are going to design the model. So as we know that Keras generally prepare sequential models. So initially we are going to call the sequential function, and then we are going to design the model using the different layers. So we are going to use conv2d, that is convolutional layer, with filter of size 64, with kernel size 3x3, and the input shape of the image is represented here. Further, we are going to use another convolutional layer, and further we are going to use max pooling layer. Similarly, this is one layer, and similarly we can use multiple layers. So multiple layers of convolutional blocks are designed, and further we have a fully connected layer to perform the final classification part. So we are going to use various loss functions. So here we have used categorical cross entropy, and we can use different optimizers. So we can use other optimizer, but here I have used Adam optimizer. And for accuracy matrix, for the performance matrix, I have used accuracy as a most important parameters. So further we are going to check out how the model has been designed. So we are going to have the summary of the model, and further we are going to train the model. So to train the model we have to use fit function, and with we can use the X train data and Y train data. So on the basis of the X value, Y, or on the basis of image, the particular label is stored, and number of epochs can be increased to increase the accuracy. So here for the time being I have used one epoch, but we can use more than one epochs. In general convention, most of the researchers used about 100 epochs to 200 epochs. So better to use more than 5 and 10 epochs. So these are this generally gradually decreases the error part, and which is most important for such learning purpose. And further we are going to use a batch size of 16, and this represents the pictorial representation of the model. Next we need to implement the confusion matrix part, for which we need to first find the Y predict, for which we are going to use the predict function, where we are going to predict the labels of X test datas, and this prediction values will be in the format of arrays of probabilities of being in the particular class or not, and then we are going to pick up the particular label as the predicted data. So for which we are going to perform here, we are going to use np.arg max for the particular purpose, and further we are going to get the labels of predicted datas, and then we already have the labels of the test datas. So now we are going to prepare the confusion matrix between the Y test data and Y predict data, and we are going to represent it in the form of heat map. So here we can see the most correlation in this diagonal part, and then we are going to have the classification report, which presents us the entire report of various classes and their precision values, recall values, F1 score and support. Even we can get the accuracy value. Here we have an accuracy of 99%. Further we are going to predict whether the particular value belongs to the particular class or not. So here we are going to predict some of the values of particular test data. Finally we can see that there is no difference between the real value and the predicted value, such as here we can see in most of the cases the predicted value is same as that of real value. So hope you have understood MNIST dataset and its implementation of convolutional neural network, and if you have any queries then please put it in the comments. So thank you all.